Okay, guys. Right, part two of this question. I stand corrected on the alpha. The alpha was 53.13, so I'll make sure we correct that in this part of the question. We are talking about. You might hear a bit of background noise. That's just my wife doing a bit of washing up in the background there. Hi, Kate. Let's get on with the question. So we are looking at this part here. It says we've got the model that we are going to use for this greenhouse temperature thing. Alright, so it says when the temperature in the greenhouse is 20 degrees, what time of day is it? And it has to be after midday. And the question is saying that T starts at 5 o'clock in the morning and it won't exceed 17 hours after that. The model runs from 5 o'clock in the morning plus 17 hours. So we need to write out the model again, but using the simplified version from the first part. So we've got G is equal to 17 plus 5 sine theta, and it was minus 53.13. That was the actual alpha value. I looked it up. Alright, I've forgotten. And I haven't got a calculator for this part either. So, see how we get on. Now, I have made a little error in the model here because theta, I've got to replace. If you see here, theta is now changed to 15t. So this part of our model should be 15t. Alright, and it says, when is the temperature, which is G, when is the temperature at 20? So when temperature is obviously going up and down throughout the day, when does it get to 20? So set it equal to 20. I'll write out the complete correct formula now. Give me a nice chance to do that. So we've got 15t minus 53.13. And it's just a case of solving this equation. So I'm going to be doing quite a few steps at once here. So let's do 20. Let's take away the 17 from here. And let's divide through by 5. Then that will leave us with a nice, something in terms of just sine 15t minus 53.13. Okay, lovely. This is going to be 3 over 5. So we've got 3/5. We've got sine theta there, so I can do this all in one go. Let's just take the sine theta across. Sine theta to the minus 1. Of 3/5. The 3/5 is coming from here. This cancels down to 3/5. The two solutions that I have for this are going to be 86. That's my first solution. That's kind of like here. Second one is over here, which is 180. Minus 36.86, which is going to be 143. Correction there. 143.13. Okay. So, if I use the first solution, I will not get a time that is past midday in hours. It's the second solution that I really want to use. Alright, so I'm going to use it up here. So I'm going to have this second solution, which is 143.13 is equal to, and the rest of this we haven't used it, it's 15t minus 53. So bring that back. 15t minus 53.13. And obviously I'm trying to find t, isolate t. So let's write out what this would be. 143.13 plus the 53.13 divided through by the 15. That's going to give me t. Work that out on a calculator. And you should get 13.08 as your t value. Okay? But remember, the model started at 5 o'clock, so this is 13.08 hours after 5 o'clock. So let's add 5 to this to get a time. So we're talking about 18, so 6 o'clock, or 18 hours I should say. 18 hours, 0.08 minutes. Now, you're going to need to convert this into what is 0.08 of an hour. Turns out to be 5 minutes. So the actual answer is 6:05 in actual time. That is 18.08 hours from 5 o'clock. Convert that and you get 18.085. So that is the time that the temperature reached